All right, this is going to be the first video for Notes 5, and it's going to be on the exponent rules, and there's a few of them. Now, we've talked in the past about what's called the product rule, and the product rule says when you multiply, and I'm going to add a couple words here, when you multiply like bases, you add exponents. So our lovely example here, we've got x squared times x to the third, which then becomes x to the fifth, right? 2 plus 3 makes the 5. So that's the product rule. I'm going to say it wrong. All right. When you raise a power to a power, you multiply. This one's called the power rule, right? Power to a power. So the example here is if you've got x to the third here, and then you're raising it to the power of 4. So I'm going to zoom in a little bit. So both of these are exponents, right? Both of them are powers. That becomes x to the 12th because you took 3 times 4. All right, so that's the power rule. So product rule, when you're multiplying like bases, you add the exponents. Power rule, when you have a power raised to a power, you multiply. Okay. When you're combining like terms, so adding or subtracting like terms, you simply add the coefficients, but the exponents do not change. So you've got an x squared here and an x squared here. Look, the answer still has an x squared in it, but the 3 plus 6 made the 9 here. X to the fourth plus x to the fourth is still an x to the fourth, except you had 1 here becomes the 2 there. All right. M to the fourth and M to the third, folks, those aren't like. So because they're not like, look, there is no change from left to right. So no worries there. And then the last exponent rule is what happens when you are dividing like bases. And in that case, you subtract the exponents. So you had x to the 8th, but we're going to divide out x to the 2nd. So 8 minus 2 makes our x to the 6th. So we're going to put these exponent rules to, I'm not going to say to the test, but we're going to simplify question 1 through 4. And they do get kind of progressively more complicated in some ways. So let's get into these first couple. All right, so for part A here, this is a power rule. All right, so power rule. And we're going to do, why do I have P there? How about X? 5 times 2 is 10. All right, so this is what I get for doing these videos when I need to take a nap, apparently. All right, and then for the next one, this is going to be product rule. All right, and product rule says that when you've got those like bases being multiplied, you add the exponents. All right, so P to the 7th here. All right, and part C is a little bit of a combination of a couple things. It is your product rule because you are multiplying. That's what the parentheses right next to each other mean. But we've got to be careful because while the product rule tells us for exponents that we add those together, so it's going to be k to the 5th here, right? 3 plus 2 makes 5. However, that doesn't have anything to do with the 4 and the 8. The 4 and the 8 are still being multiplied. So we're going to do normal multiplication for 4 times 8 and create 32. Okay, so just be careful that you know when you're adding your exponents versus when you're multiplying coefficients, and try not to confuse the two. All right, so that's A through C. I'm going to slide on over and we'll get D and E up here. D and E are dealing with like terms or not like terms as the case may be. So for part D, we've got XY and XY and XY. Those are all the exact same thing, right? Like terms, same variables, same powers. We don't even have exponents on here that are written, so cool. We'll go with that. So this means we've got 7 minus 3. So that's going to be 4xy. And then 4 plus 9 is going to be a grand total of 13xy. So all of those were like terms that you could combine. Part E, let's see what we got here. We've got x to the 6th, x to the 6th. That is not an x to the 6th. So you can only combine the x to the 6th terms. Let's see, 8 plus 9 makes 17x to the 6th. And then this term doesn't disappear, doesn't run off your paper. It just stays as, negative 4x to the 3rd. Those aren't like, don't try and combine them, just let them be what they are. All right, so that's D and E here. And F is kind of hiding off to the side here. So F is quotient rule. All right. And quotient rule deals with your division. So we have a couple terms being divided here, which means we're going to subtract. 5 minus 3 makes 2. Okay. So that's the first line of those problems. Okay. A couple of little simple ones, a couple more complicated in terms of the coefficients there in part C. All right, 2, 3, and 4 get kind of progressively more complicated, especially 2 and 3 here, where we've got whole little parenthesis sets, 2 powers. So let me really zoom in here on number 2. So each piece of what's inside the parenthesis set is going to get that power of 3. All right, and this only works because we're dealing with multiplication inside. So we're going to have 3 to the third. We're going to have x cubed to the third, and then we're going to have y to the 5th to the third. And we're going to just deal with each of those pieces separately. So 3 to the third means I've got 3 times 3 times 3, which is 27. So there's my 27. X squared to the third. Power rule tells me I need to multiply. So x to the 6th. And for the y terms here, again, power rule tells me I have to multiply. So y to the 15th. All right. So there's number 2 simplified. Okay. And then if I move over to number 3, we're going to do the same thing. We're going to simplify this part. Separately, I'm going to simplify that part, and then ultimately, I'm going to multiply both those answers together. All right, so I'm going to take this first part. We've got 2 squared, m squared squared, n to the 4th squared, and then I'm going to deal with the other kind of parentheses set here, which is, let's see, 3 squared, m squared. I ran out of room because I write too large. N cubed squared. All right, that's a lot of squares and cubes and things and such. But now I'm just going to do parts and pieces. So I'm going to take the numbers, deal with those as I would normally, and then each one of these variables, I will deal with the power rule. All right, so let's see. We've got 2 squared, which is 4. Then we've got 2 times 2 makes 4. N, 4 times 2 makes 8. Let's see. I'll change colors because I can. 3 squared makes 9. That's going to be m squared. There is a 1 sitting there. If you want to put it, you could. And then n to the 6th. All right, so now I'm going to take this green expression here times that lovely purple expression right there. I will use orange because I can. Multiplying what I can. So 4 times 9, so coefficient times coefficient. That's going to be 36. M, this is product rule. So m to the 4th times m to the 2nd. That's going to be m to the 6th. And n, I've got 8 plus 6. I'm kind of feeling a 14 there. So it should be 36, m to the 6th, n to the 14th. All right. And that's pretty complicated because you've got power rule, you've got product rule, you're dealing with numeric coefficients, the variables, so much stuff going on. Take it apart in pieces and just make sure you're going slow with it to get all the stuff in there. All right. And last but not least, back to something that we've been doing for a while, which is, and I don't want to say simply, but this is just, and I am going to say just dealing with like terms. So we've got x squared here. We've got an x squared here. We can combine those. So 3x squared minus 2x squared is simply going to be an x squared. If you wanted to put a 1 there, you could. I'm not going to. And then you've got positive 4x and a positive 8x. That's going to get me a positive 12x. And that is simplified because I've combined the like terms. All right, so that is the first part of Notes 5 on the exponent rules. As always, let me know if you have any questions or concerns.